Alright, today's lecture we're going to be talking about classes and objects. So we did have a previous lecture where I kind of went over the top level view of what classes and objects actually are. Where today's lecture is going to be a lot more about the syntax and how to use those classes and objects. So just to kind of reiterate what we've gone over in the past, is a class is just a user-defined type. It's sort of like a blueprint. So remember, this class is the blueprint, but when we actually instantiate it, that's where we create the object. That's the actual house. And again, when you get that object reference not set to an instance of an object error in the future, which we all do, that's what it means. That sometime, somewhere you didn't use that new keyword and you tried to access an object reference that wasn't pointing to an actual object. So within our class, one of the things, some different concepts that you just need to hear about and learn is one is encapsulation. And encapsulation is just this idea that you use a class to wrap together attributes and methods. So you're encapsulating what it means to be this class. So if you had an employee class, you would encapsulate, like for instance, attributes like employee number, their social security number, salary, etc., etc. Those would be the attributes, and then the methods would be something like, insert a new employee into the database, or delete an employee, whatever that method could be. And again, you're encapsulating all of that into a class to organize that class. And when you're first creating your applications, that's one of the things you want to do is you want to sit down and architect out what classes am I going to need. And then what happens is as you start prototyping the application, as you get your head wrapped around this application more, you start realizing more and more classes that you're going to have within your application. Now, the next idea that we want to talk about is encapsulation. So for example, we have this public class called time1. Now encapsulation is where objects can hide their implementation from other objects. And what that really means is that you have private attributes, which means the outside world has no idea that this exists. So if you gave someone this time1 class to use, they wouldn't be able to even know that it has an I/hour variable. They could only see things that were public. And this also goes for methods. So if you have a private method, it can't be used. It's supposed to be just used internally. So let's go ahead now. Let's take a look at this basic class example and walk through it. So one thing you want to be careful of is this public keyword right here. Because I don't know why, but when you create a new class in C#, so for example, if I were to come over here and say add a class, and we'll just leave it as class 1. You'll notice when I add it, it uses this internal keyword, or sometimes it'll just do this. And the problem with that is this makes it private by default. So it kind of really messes things up and it makes it hard to use. So I'm going to go ahead and just delete that out of the application for now. So just make sure your class has this public keyword on it. Now, for our data hiding, we have this private keyword called I/hour. So that's going to keep track of the hour for our time class when we actually instantiate the object. Now because this is private, if we instantiate an object, we say my time1 dot, I/hour is not going to come out. So if we want the user to be able to get or set I/hour, we have to have a way for them to do that. And we do that through what are called properties. And so property has a slightly different syntax. It looks a lot like a method, but you'll notice it doesn't have the open and close parentheses. That's how you know it's a property. And so we've got our private variable, and in order to access it, we use a public property. So you always want to create private attributes with public properties to give them access. Now, why would you want to do this? Why would you only not just make this I/hour variable private to begin with? Well, there's several reasons. So one is, we'll talk later on about data binding. And data binding, when you're binding an object to a UI control, you do that via public properties. And so again, we'll cover that in a later lecture. The other reason is that you want control. Like you want to think of this data that you have within your class as just sacred. And you want to control it, and you want to control what goes in and out of this particular variable. And so now, a lot of times, you would just have a public get and set like this, just because in the future, you may want to validate I/hour. So for example, I may want to put code in here so that I only allow valid values for I/hour. So that would be a reason why this set would have more in it. Because you can see if this was just public, then the user could set it to anything they want. And now here they can set it to anything they want, but we may only want 0 through 24 values, or 0 through 23, whatever it is. Same thing with here. Maybe we want to do something before we actually return that value to the end user. So that's the concept of a private variable with a public value to get it, public property. Now here is a concept, what's called auto-implemented properties. And these are handy because what they recognized is that almost always you're going to be doing some syntax like this, with a private attribute, public property that does nothing else than return and sets it. So they came up with this auto-implement properties where you just define the public property. What this actually does behind the scenes, actually creates a private variable called minute behind the scenes, or it's named something like that. Now you don't use it. Even within your class, you just reference minute. So even in here, I would just say minute if I wanted to set it to something. Okay, so I can set it to whatever I want. This is just calling this public property, but behind the scenes it created a private variable for me. Next concept is the idea of a constructor. So a constructor is what's called when you use that new keyword and you instantiate that object. Now this is a default constructor, and you could put anything you wanted in here. This could have 1,000 lines of code if you wanted, and it's generally used to initialize your private variables, or it's set up your class in some way. So just think of, hey, when the very first time I create this object, I want A, B, and C to happen every single time. Well, the constructor is where you put that. And the default constructor is where that goes. We'll talk later on about non-default constructors that pass in various parameters. So as we come down here, we've got a method now called setTime. Now you can see that this method is public and it takes in 3 parameters. So that means this method can be used by an object and be used outside this class. And so you can notice it just validates some stuff. Don't worry too much about this throw stuff. It's just throwing an exception, which we'll learn about in a later chapter. Another method here is this universal string. And so basically all they're saying is, hey, we just want to format the data. And then down here, you'll notice that they were doing a public override of toString. Now, we're going to cover the override keyword in later lectures. But what this means is that if I come up here, and that we always need to remember that every object is inherited from the base class object. And we can actually prove that. If I right click on here, you can see go to base, or go to the base class that we're inheriting from. And you notice when I do that, we come up to public class object, because everything in C# has to inherit from the object class. We'll go over inheritance in a later lecture more. But that object base class has a method called toString that you would get for free. However, it's not going to make any sense for to say, time1 dot, whatever your object, my time1 dot toString, because it's going to call the base class as toString. So you can override it so that it'll actually, when you call toString on your object, it makes sense. So you can print out a string that represents your object. So that's what override does. Say, as I say, call this toString method, not the base class's toString method. So the other thing I want to notice before we go to the other actually implementing this class is that you'll notice that there's no namespace up here. And that makes it part of what's called the default namespace. So just keep that in mind as we come over here to this part and we actually start using our object. Now you can notice we can use the var keyword, or we could just do something like this and just say time1 equals a new time1. Now remember, we could have also done this on 2 lines. This creates the object reference. This actually instantiates the object. And so what you wouldn't want to do is to say time dot, to universal string, for instance. This is going to throw an error if I do something like this, because I have not instantiated the object yet. And this is something that happens all the time in code. But what we've done here is we created our object reference. We've actually created the house here. We've created that blueprint. And so now we have an individual time1 object. Now if we wanted to, we could have instantiated as many objects as we wanted of this class. So I could just come in here and I could say, this is my time2 object. And I could do this for as many times as I wanted. Each one is its own separate object. And this is a concept that students really struggle with. So these are completely separate. They're just, imagine your house and your neighbor's house, right? They have different carpet, different chairs, different windows, etc., etc. That's the same thing. These are 2 completely separate objects. So that means that each one has a separate hour, minute, and second within them. Now let's go ahead and take a look at how we actually use this class. So here's our time1 object. And we can see now we can call this toUniversal string. So if we came back over here, why can we call that? Because it was public. If I were to change this to private, and then I come over here, you'll see that now it doesn't know what toUniversal string is. It even tells me it's inaccessible due to its protection level. So it knows about it, but it says, hey, you can't use that because this is a private method. So let's leave that public so that over here we can now use these public methods. Now here's that override. So since we overrode the toString method, if I were to right click and do go to definition, you can see this is the method it's going to call. It's not going to call the base classes method. So if I go to base, there is a toString right here. And it's not going to call this one. It's going to call the one that I overrode, the one that makes sense to call for this given object. Down here, you can see that we're going to call that public method setTime and pass in the variables. And down here, we're just using the methods again. So that's the very basis of how we create our class. Now, it's one thing to learn the syntax, but again, in this class I've constantly tried to hammer in, how you actually do things, not just the syntax of it. And while it's important to cover the syntax and try to get your head wrapped around it, the other thing you want to practice is when you look at a problem, like for instance one of our assignments, is first thing you should say is, what classes am I going to need to solve this problem? Again, if there's employees or a time class, math class, whatever it is, you have to come up with that first before you can actually solve the problem. Okay, let's take a look at another example here. So now in this example, let's go back so I can show you the difference here. You notice in this one, they actually had a separate file that contained the class. I personally prefer this type of syntax rather than putting the class in the same file as other code, but you can. So you'll notice in this one they've got the public class and it's all part of this one file here that's a part of the main method. Again, you can do this, I usually don't. So now in this one we're going to learn about this keyword. So here we have 3 private variables. We have a public non-default constructor. So you can see it has the same name as my class, but here we're saying if you want to use this non-default constructor, basically saying when you use the new keyword, then you have to pass in hours, minutes, and seconds. So when you pass in those hour, minutes, and seconds, you can see that this hour is exactly the same name as this hour. Now I recommend you don't do this, but you can. And so then the question is well, how do you reference this one versus this one? Well, you use what's called the this keyword. So the this keyword makes it so you reference this object, the object I'm currently dealing with. So you notice if I highlight this, if I were to use just the word hour, it's referring to this parameter, not the class level variable. And again, I would recommend just never doing it this way, but a lot of people like it this way, but it's not for me. It just seems to confuse things. And then down here you can just see that we've got these various methods where we needed to use the this keyword in order to reference this data. Let's go ahead and go to the next example. This one we're going to use some more overloaded constructors. So we've got the private variable here. We have an overloaded constructor here where we can pass in the hour, the minute, and the second. But oh, by the way, you don't have to. You can choose which ones you actually pass in because it's actually set a default value for them. Now down here, we've also got a public object, a public constructor. You'll notice it actually takes in a time2 object. So what you're doing is you're passing an entire separate object. Then this little strange syntax right here, it's a little easier to read on one line. We're saying, oh, just call the this other non-default constructor. That's what this keyword. See how it highlights this? And then you just pass in each attribute. So you're just accessing the properties, the minute, the hour, and the second of whatever object is passed in here. So it's just another way that you can do it. And then you can see we've got a public to set time, a public property to set the hour, minute, and things like that. Let's take a look how you actually implement this now. So you can see we're actually setting it all kinds of different ways. The first way is is the default constructor. Now you notice we don't actually have a default constructor over here because we get it for free, and because nothing is actually going to run. But you'll notice it has those empty parameters here. Now if you want to, we can call this one here. Now you'll notice even when I highlight this, you can see that it comes up with each of the 3 parameters, but you can choose, how you want to pass those in. So you can see here, they're choosing just to pass in the hour and the minutes. Here, they're hour, minutes, and seconds. Now here, you can see that they've created this time2 object called T4, and they've decided to pass that in here. So see, this one object already contains all of this data because it has its own unique, hour, minutes, and seconds. And so when we call this constructor, you can see I pass in that whole object, and then I just access its properties to pass in the actual values. So that's how that works there. Okay, let's take a look at our next example. So this one's going to introduce what's called the static keyword. Now the static keyword essentially means that this variable here, there's only one of these variables in memory, and it does not belong to any object that's created of type employee. Now that's a little bit confusing, but what it really means is that anywhere in this code you can refer to count like they are, but it doesn't belong to any object that's been instantiated. And as we look at examples, I think that'll make more and more sense. So there's only one of these count variables no matter how many employees you instantiate. We'll look at that in just a second. But now every employee object does have its own unique first name and last name that we set right here. Now what you'll notice they're doing is that in this employee constructor, they're incrementing the count. So what they're basically keeping a track of is how many employee objects have been instantiated, because there's only one static count. In all intents and purposes, this is kind of like a global variable. And we'll show you how you access that in just a second. The other thing I want to talk about is destructors, but I'm going to save that for just a second. But let's finish talking about static methods. So over here, you'll notice that we have employee.count. Now this is a new syntax because this is the first time where all we've done, you'll notice, is just reference the employee class, not an object of that employee class. Do you see the difference there? So so far we've said, employee E1 equals a new employee, and this instantiates an employee object for us. Up here we're saying our class name dot. So when we do that, only thing that's going to pop up here are our static methods. Now we've actually been using static methods all along. For example, the math class. When we say math dot, notice how all of these methods pop up, whether the methods or properties. That's because they're static. Because it's just the idea that you didn't need to instantiate an object so it have its own state. It didn't need a bunch of attributes associated with it. We just wanted to say, hey, if you want to use this math class, you'll need to instantiate it. Just use this max method or the min method or pi because it's static. So there's only one in all of memory that exists, just like this count variable. No matter how many employees we instantiate, there's only one count. So what they're trying to show you here is this is going to return 0 because the count hasn't been called yet. After this, count is going to be set to 1. After this, count is going to be set to 2. So this is going to print out count. This is trying to show you that there's two completely separate objects that contain two different first and last names. All right, so the next concept we want to talk about is garbage collection. So in say like your C++ class, you probably had to worry about objects and how you release their memory. In C#, for the most part, you don't have to because it has something called a garbage collector. So what the garbage collector does is it just runs in the background automatically. Occasionally it wakes up and it figures out, hey, look at your code and what objects have been instantiated that it's impossible for them to be referenced anymore. So what I mean by that is, let's just pretend that this code is a lot more complicated than it is. But you'll notice that as soon as I instantiate this object has to exist from right here to right here. Because just pretend this was a million lines of code in between here. So because of that, the garbage collector would never collect this object until right here. So what happens is it creates the object in memory, And then after this little bracket here, the garbage collector marks that object for collection. And then when it is available to it, it deletes that from the memory. So it does it for you automatically. And that's the difference between managed and unmanaged codes. So in C or C++, if you failed to release those resources, it would be something called a memory leak. Now in C#, you can have memory leaks, but it's generally not the same. It's not the same exact thing as in C or C++. Generally, memory leak means that somehow you're constantly instantiating new objects, but for some reason the garbage collector doesn't think. They can still be referenced, so it won't get rid of them. And I have had that happen before, but for the most part, the garbage collector works really well. And it's extremely complicated, and they constantly update how the garbage collector works, and it gets more and more efficient over time so that it uses less of the CPU behind the scenes. Now, we do not know when that garbage collector is going to run. And so that's always kind of tricky. So just keep that in mind. Now, the next I want to talk about is a destructor. Now, you've probably used this in other languages, but it has kind of a unique feature for C#. Now, the garbage collector, when it runs and it's cleaning up this object, it will clean up the memory for us, but before it does that, it will call our destructor if we have one. Now, you don't need to clean up objects in here. So if we had instantiated some objects up here, you wouldn't have to worry about setting them to null or anything like that. However, if there were unmanaged resources, such as like maybe a reference to a file, a reference to a database, some connection that was open that you want to force to close it, if they didn't do it properly and you want to make sure, hey, this class is going out of existence, so let's make sure we close those connections, you could do that in the constructor because you're guaranteed that the garbage collector will call this. You just don't know when it will. Now over here, you can see that when they instantiated these objects, they did end up setting them to null. Now, when you set this to null, it resets it to where it's just an empty object reference. So after this, we could, if we wanted to, say E equals a new employee class. So we could say something like that, and it would just generate a whole brand new object in memory. This one would just null out where that pointer was going to. So it would kind of clean up the memory for us. Generally, you don't have to do this because C# is going to do it for you. So, but again, you can if you want to. And sometimes it makes sense because some of these objects, or maybe you have a list or a collection of objects that might take up a lot of memory, and you want to reclaim that memory as fast as possible. So you're trying to make it clear to the garbage collector, hey, I'm not going to use these anymore. Go ahead and clean them up. So now let's talk about, or actually let's just kind of recap everything we learned about today. So here's an example that I've created, this classes and objects example. So let's just walk through it. So first, I've got a private attribute that's the make of a car. So you can see we've got this class vehicle here. We want to make sure that's public. We've got our class vehicle. And so we're going to have a make. That's a private attribute. You can see we have this XML comment here. We have our private string model. And we have a public color. So I'm doing this just so when we actually instantiate an object of this type, we can see which actually pops up in the IntelliSense and use it. So now here's a new concept, the const and read-only keywords. So if you want to use a constant in C#, use the constant keyword. Now when you use a constant, you have to initialize it as soon as you create it. You have to do this. And from here on, it can never be changed. It's a constant. Also, constants are by default static. Because when you think about it, since they can never change, why instantiate this constant variable over and over again and just take up memory? Why not just create one? Because it can never change. Now, sometimes you want the idea of a constant, but you want to be able to set it at runtime. Well, that's where the read-only keyword comes in. So the top speed is a constant, but it has to be set in the constructor for your class. And the second it's set, it can't be set again. So again, it's nice to be able to set a constant at runtime, and that's what the read-only keyword does. Next, we're just going to create a static variable called iNumber of vehicles. Essentially, every time we instantiate the vehicle class, we're going to increment iNumber of vehicles. So no matter how many objects we instantiate, This private static variable, there's only one in memory. We can instantiate 1,000 vehicle objects, but there's only one I number of vehicles that all of those objects share. Here we've got our default constructor. We're just going to initialize all of our variables and increment that static variable. Here we're going to have a non-default constructor, basically doing the same thing, but this one pass in top speed. Another one we're going to pass in all of the data. So just various ways that we just kind of think of, hey, what are the different ways a user may use our class? So they may only know the top speed. They may only know everything, or they may not know anything. So you just want to give as many options to create your class as possible. Now here we're going to have some public properties in order to access our private make and our private model. Now we didn't have to create one for our public color because it was public. Now remember, this is something you wouldn't want to do in your code. Now we come down here and you'll notice that in order to access this I number of vehicles via property, we have to create a public static property, and that returns I number of vehicles. Now we're going to actually create a public static method. So this is what they did in the math class in order to create a static method. Now just like static attributes, this method startVehicle does not belong to a vehicle object. It belongs to a vehicle class. So startVehicle is a method that is shared from all classes. And all it's going to do is return how many number of vehicles. Now I put this note in here because this is a static method. So what does it mean to access sColor? So if I were to come up here, you can see that we have these various private attributes, our public attribute, and this one called sColor. So why is sColor, equal to anything not valid? Like, why can't it say this? Well, you can see it tells us an object reference is required for a non-static field. Well, what in the world does that mean? Well, let's think through this. So if I were to instantiate a vehicle object, and then I instantiate another vehicle object, they both share this start vehicle. So which object would sColor even refer to? Remember, we could have 1,000 vehicle objects, each with their own individual sColor. Well, in order to access start vehicle, we're going to say vehicle dot start vehicle, not the name of our object dot start vehicle. So you cannot access attributes of the class in a static method. I've also got another static method over here that does the same sort of a thing. Then we've got a private method, just to show you that outside of the class we can't access this. In here, I wanted to show you that a normal method can access static variables because it sort of belongs to every object. And then down here I just want to show you, here's a syntax for how you do a public method for our class that can be seen outside. So now let's go ahead and use our class that we've created. So we've got our form over here, and you notice we're going to instantiate 3 vehicle classes. Let's come back over here to our vehicle class, scroll to the top. Now you'll notice that here's this namespace here. Now it put this in here for me because I created this vehicle in the same namespace, this project, as my form. So it did this for me. Now you'll notice that they're both in the same namespace. If this was a different namespace, the second I do that, look what happens to my vehicle class. It doesn't know how to access it. And if I were to highlight this, you can see that, hey, did you really mean to use this class, this name that was in this namespace? And now suddenly it knows what the vehicle class is. So again, just remember what the point of these namespaces actually do. So again, if they're the same namespace, you don't have to use any using keyword, but if they're different namespaces, you have to use the using keyword. Now inside this method, this start click button, it doesn't really matter, we're going to instantiate 3 objects, and we're going to instantiate it 3 different ways by calling the different constructors. Now we're going to access in our vehicle 1, we're going to set the make, model, and color. Now you'll notice this is our public property. This is our public property. So if I do go to definition, it's accessing the public property which accesses the private variable sMake. Here, this is a public attribute, so we can access it directly. So here's my public one. But for example, sModel, so if I were to come over here and say myvehicle1.sModel, it doesn't see that. It doesn't know how to access it because it's private. So that's data hiding. So we're hiding that implementation. So we're saying, hey, we want you to access these, but we don't want you to access that private variable. Now we come down here. Now notice here we're using the name of the class, not an object. And that's how we can access the static attributes or static methods. In this case, start vehicle. So it's just, in this case, it's going to print out basically 3. Because if we go to start vehicle, we're going to print out some string with how many vehicles have been instantiated. This gets set every time our constructor gets called. Now when we actually use an object, only public attributes and public properties and public methods will show up here. Things like make and model, or this is a public method. But you'll notice this is a private method, does not show up. So in this case, maybe this application, we had to deal with various vehicles. So we could create vehicles, we could create classes of cars and trucks, or whatever else is gonna make sense for this particular application. So the last bit that I want to show you is just kind of drill in the IntelliSense a little bit more and why it's so important to always use XML comments for all of your attributes and your methods. And the reason for that is a lot of times you may give other developers a DLL that contains your class, or you may give them this code, but they don't want to have to figure out how to use it. They just want to care how to use the top level methods. So what you do is you'll notice throughout my IntelliSense that if I go into these various, make for instance, or this is a public method, you can read, it's a public method. This is method may be seen outside this class. So you can see we're using the IntelliSense in order to tell the user how to use this method or what it does. The other thing is that you can do what's called reverse engineering, where you take this code and you reverse engineer it into a UML diagram in order to give people, because some people may not understand how to read code, but they can understand how to read a UML diagram. And so what that would do is all of your forms, all of your classes and data types, they would all be shown in a graphical form so that people can see how they relate to one another and kind of understand the flow of your program. And you could do that, again, right within Visual Studio, where you can reverse engineer it and turn it into some sort of design document. So that's our lecture on classes. I hope you just kind of jump in, create some classes for your own, instantiate objects, play with static methods, public and private properties, and I think hopefully over time it'll start to sink in. Thanks.